This lesson is going to review the powers with the same base. We're going to evaluate them, find values, rewrite them, things like that. So in this first example, we're going to evaluate the powers of 3 to find each value. So basically what we're going to do is we're going to rewrite them if needed and then find the actual value. So 3 to the negative 2 is equal to 1 over 3 squared. And so that's 1 over 3 times 3, which is 1 over 9. Remember, if we have a negative exponent, we want to rewrite that so it's positive. 3 to the 0, well, we know anything to the 0 power is going to equal 1. The value of 3 to the 1 is just 3 one time, and that is equal to 3. And the value of 3 to the 3rd power is equal to 3 times 3 times 3, so that is equal to 27. So when we're finding the value, we're actually not just rewriting it, but we're actually finding the value. So consider this expression, 5 to the 3rd times 5 to the 6th. In expanded form, it's 5 times 5 times 5 times 5 times 5, 6 times. What does this expression simplify to? Well, we can rewrite this. We can just count up all. This is the same thing as saying 5 times 5 times 5. We can write it all in one big thing. So 1, 2, 3, 4, 5, 6 more. 1, 2, 3, 4, 5, 6. And then we count them 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 5 to the 9th. So when we're looking at them, we can rewrite these very simply by, remember, we're going to add the exponents. When we're multiplying with the same base, we are adding the exponents. So 5 times negative 3 is 5 times a negative 3 plus a negative 3, which is equal to 5 to the negative 6th, which is equal to 1 over 5 to the 6th. And if we were to find the value of that, we would say 5 to the 6th is equal to, that'd be 1 over 15,625. We don't always go all the way to this, but you can, that's the value. So 5 to the 7th times 5 to the 3rd is 5 to the 7 plus 3 is equal to 5 to the 10th. In this case, we've got 5 to the negative 4 plus 4 plus 0. Well, negative 4 plus 4 is 0, plus 0 equals 0, and we know that equals 1. That was an easy one to evaluate. 5 times 5 to the 3rd, remember 5 to the, just 5 is the same as 5 to the 1st, plus 5 to the 3rd, or times 5 to the 3rd is 1 plus 3, so that would be 5 to the 4th. Sometimes we forget that there's an exponent there, so make sure that if it doesn't have an exponent, that's actually a 1. And then this is 5 to the 6th times 5 to the negative 4th is 5 to the 6th plus a negative 4. And 6 plus a negative 4 is 5 squared. So which ones of these are equivalent to 3 squared times 3 to the 4th? Well, let's just figure this out. 3 squared is times 3 to the 4th is 3 to the 2 plus 4, which equals 3 to the 6th. So let's check all that apply. So anything that works out to be 3 to the 6th, that's true. Well, 3 to the 6th is. 3 to the 8th, no. 9 to the 6th, that's a different base, so that's not. Let's try this one. Negative 4 plus 10. Well, that's equal to 3 to the negative 4 plus 10, which is 3 to the 6th. So that is actually the same thing because it simplifies to 3 to the 6th. 3 to the 0 times 3 to the 8th. Well, 0 plus 8 equals, that'd be 3 to the 8th, so that is not the same. 3 to the 3rd times 3 to the 3rd is 3 to the 3 plus 3. 3 to the 6th. That's also going to get us our same value. This one, 3 times 2 times 3 times 4. Well, we don't even have the same bases here. This would be 3 squared and then times 2 times 4. So that's not the same thing. We don't have all the same base. This one we have 1, 2, 3, 4, 5, 6, 3. So we could rewrite that as 3 to 6. So that is also a similar thing. So if you just follow the rules, you can figure out which ones are the same. So in this case, we want to figure out what the variables a, b, and c are when we're simplifying this. So we have a to the b equals c. So if we have them, if they're a fraction, we subtract the variables. So this is 3 to the 8 minus 4, which is 3 to the 4th. So our base a is 3, our exponent b is 4, and then our value is if we take 3 times 3 times 3 times 3, which is equal to 81. Because we've got 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 equals 81. So here's an example. 4-student simplified expression. Which one did it right? So Camilla added the exponents and got 4 to the 15th. Bentley divided and got 4 squared. Mira multiplied and got 4 to the 50, and Regan subtracted and got 4 to the 5th. Which one's correct? Well, we know that if we are dividing the same bases, we subtract the exponents. So which one was correct? Well, this one. 4 to the 10 minus 5, it should be 4 to the 5th. So determine the value of the variable in each expression. We have 9 to the negative 3 over 9 squared. Well, remember we have a negative exponent, so we want to rewrite this as 1 over 9 to the 3rd times 1 over 9 squared, which would be 1 over 9 to the, and if we're multiplying, we're going to add those exponents. So that would be m would be equal to 5. In this case, we've got the negative, both negative, so we're going to rewrite this as 1 over x to the 4th times x to the 6th over 1, which is x to the 6th over x to the 4th. We're dividing, so we're going to subtract, and we're going to get x squared. 6 minus 4 is 2, so n is equal to 2. What is the value of c? So we're trying to find what power we're taking negative 11 to. So the base, is negative 11. So this is equal to negative 11, 7 minus 0, which is the same thing as saying a negative 11 to the 7th power. So c equals 7. So if you have any questions on that, hopefully that's a good review for you.